What's up, math fans? I'm still doing radicals. Now I want to evaluate what a rational exponent is, okay? So a rational exponent, first of all, the word ratio just means a fraction. So if you see an exponent here is 25 to the 3/2 power. If you see an exponent that's a fraction, it might look a little overwhelming. It's not, and I'm going to show you how to break it down. First of all, I ask you an easy question. What's the square root of 25? Hopefully you know your perfect squares by now because I keep saying it. So the square root of 25 is 5. But why? Blurting out that it's 5 or going to the calculator and figuring out that it's 5 is nice, but it's nice to understand why. The square root of 25 is 5 because you're looking for something times itself twice. That gives you 25. Well, 5 times 5 is 25. So let me go over here now. What's the square root of x to the 16th? People see that 16 and they go, oh, I know my perfect squares. I think it's x to the 4th because 4 times 4 is 16. But that is not a 16. X to the 16th is very different than plain 16. So you're asking yourself what times itself gives you x to the 16th? And that answer is x to the 8th. X to the 8th. Because x to the 8th times itself, x to the 8th times another x to the 8th, is x to the 16th. Why? Because you add. When you multiply powers, you actually add the exponents, and 8 plus 8 gives you back to 16. Alright? So here's some background knowledge that you should have from your career in mathematics. You should know that if you're multiplying with the same base, you add the exponents. You should know that when you're dividing with the same base, you subtract the exponents. And don't forget, the base stays the same. Same base, same base, same base. Same base, same base, same base. So that x just represents a number or another letter. It could be anything. It just has to be the same base, and you keep the same base. All right? You don't cancel out the x's. Here, x to the a power. So now we have a power raised to a higher power. I'm talking about math here. Here you multiply the powers, and you keep the base. And finally, if you have a rational comes from ratio, a rational exponent. A rational exponent is a numerator over a denominator, a over b. The numerator, the top number, stays as the exponent. Top number, still top number. But the bottom number becomes the index, and I've discussed in other videos, like adding and subtracting radicals, you should see that one, what an index is. So the b stays your index, the bth root, they call this. If it was a 2, it would be the square root. If it was a 3, it would be the cube root. 4 would be the 4th root. B is the bth root, okay? Keep that in mind. So I'm going to go over here, and I know that I have to add exponents, so I know it's x to the 8th. Now let's go over here, x to the 6th. So again, don't panic because 6 is not a perfect square. It doesn't matter what times itself gives you x to the 6th. That's x to the 3rd. Now if you evaluate what you did here and here, you'll notice, well, that 3 is half of 6, and 8 is half of 16. So you're actually not taking the square root of the exponent, you're actually looking for half of the exponent. And that's a key, half. We'll come back to that. Here we go. Can you tell me the square root of x to the 3rd? And a popular answer when you first learn this, immediately, oh, he just said half, he just said half. I guess it's x to the x to the 1.5, because x to the 1.5 times x to the 1.5, I just add 1.5 plus 1.5 and I get 3. And that's cool and it does make sense, but we don't want to see decimals as exponents. We want to see rational numbers. So right away, 1.5 is not acceptable. You got to think about what 1.5 is as a fraction. Well, that's 1.5. And 1.5 happens to be 3 over 2. So I would accept 3 over 2. But here's where the lesson comes in. So I'm going to come back to that 3 over 2. You might have learned to break down radicals, to simplify radicals. I think you learned this, a little tree, right? And the little tree says, what perfect square times a non-perfect square gives you that? So if I simplify this, that comes from the square root of x squared times the square root of x. Because x alone is really x to the 1st power. And 2 plus 1, we said I had the exponents, 2 plus 1 is 3. And this is good because I said in another video, choose the pair with the highest perfect square. This is the perfect square. What's the square root of x squared? Just plain x. And what's the square root of x? I don't know, so I leave it under the radical, like that. Okay? So this is the old way of doing it, where you simplify it. For this video, I'm going to show you the new way to do it, where you write it as a rational exponent. So my rational exponent, well, I just said earlier, was x to the 3 halves, because you're looking for half the exponent. Let's see if I can make that make clearer sense to you. Here, if you were going with the whole theory of taking half the exponent, right, half of 2 is 1. Here, if I ask for the square root of x, you could argue with me that, oh, that's x to the 1/2, because x to the 1/2 times x to the 1/2, 1/2 plus 1/2 is 1. So you could make this argument now. So we're uncovering new information. So what's my point is the square root of x is the same as x to the 1/2. So that is a helpful hint here. X to the 1/2 is the same as the square root of x. And that makes sense following this rule, because look, the bottom number is the index, and you don't have to write the 2 for the index, it's implied. And the top number 1 is the exponent, and you don't have to write the 1, that's also implied. But there's a 2 here and a 1 here. You don't believe me? I'll put it 2 here, 1 here, okay? But only rookies do that. You don't have to put the 2 or the 1. Other numbers, yes, but not 2 and 1. Let's move on. So, if I'm going to write this with a rational exponent, I'm no longer going to simplify it this way. I'm going to simply do this, okay? And the shortcut to all of that annoying information is this. Top number, index was 2, bottom number is 2. Simple as that. That whole explanation was to show you why it works, but it works. Top number, index, bottom number, the end. So this is the big rule, okay? In fact, I'm going to redo this now quickly. X to the 16, 16 is my numerator, and the index, again, the square root means 2. 2 is the denominator, and then you just simplify the fraction. 16 divided by 2 is 8. Look at that, x to the 8. So it works both ways. Let's do this one again. So this again is x to the 6 is the top number, the numerator, and then the index is 2, so that's the bottom number, and that is x to the 3rd. Oh, look at that, same answer, okay? And then this one, I can't simplify any further, so I leave it like that. That's with variables. Let's look at actual numbers now. 25 to the 3 halves. So now I'm asking you to go backwards. Here, we had the radical, we made the exponent. Now you have the exponent, where did it come from? Let's see. 3 was the top number, so it came from 25 to the 3rd, right? 2 is the bottom number, that means it was a square root. If it was 3, it'd be a cube root. If it was 4, it'd be a 4th root. If it was b, it'd be the bth root. So square root of 25 to the 3rd power. And it's easy to figure that out. Square root of 25 is 5. 5 to the 3rd power is, I don't know, 5 times 5 is 25, times another 5 is 125. So that is how you evaluate this, okay? Let's go here. What does this mean? 9 n to the 4th to the 1/2, I'm going to raise each part to the 1/2 power. The 9 gets raised to the 1/2 power, and the n to the 4th gets raised to the 1/2 power. And what did we say about raising a power to a power? You multiply the powers. So this is really n to the 4 times a half is 4 halves. 4 halves. Did you know that? Because 4 is really 4 over 1. Top times top, bottom times bottom. You get 4 halves. Now, 9 to the half. That means 9 to the 1st, and then this bottom piece means square root of. So that's the square root of 9 to the 1st, also known as the square root of 9, also known as 3. What about n to the 4 over 2? That's n to the 4 divided by 2 is 2. So that's n squared. Oh, that's it. Here, if I simplify this number, I get n squared. So I don't even need the radical. So my answer is 3n squared. That was too easy. Last one, try it on your own and then watch me. So here, let me just rewrite this. So here I was practicing writing the exponent as a radical. Now I'm going to go backwards and write the radical as an exponent. So here I want to see, let's see, 3k, 5th is the exponent, so I know 5th is the top number, 5 is the top number. And then again the index, which was a hidden 2, it's been a hidden 2 in most of them. I didn't do any cube roots today. That means the bottom number is 2, and it's as simple as that, okay? I did it all where the bottom number was a 2, but the same theory applies if the bottom number was a 3. I'll give you a quick example. let's say you were doing 8 to the 1/3. 8 to the 1/3 is what? Let me see, that's the cube root of 8. Okay, first time we got a cube root, actual index there. That means what times what times what? 3 times is 8. Well, I'll give you a hint. The answer is 2. See ya.